In this exercise, we're going to use spreadsheet formulas to do a few calculations on some data that we've been given about Alaska weather conditions. The data is in US measurements, so degrees Fahrenheit, miles per hour, inches, and we're going to convert that to metric, and then also calculate a wind chill. Now we begin with the data, the spreadsheets that it's shown here, and right from the start we need to make it maybe a little bigger so we can see all the columns. So I'll select the entire worksheet, this little space here, and then double click between any two column title letters to automatically expand the columns as wide as I need them. In the first step that we'll do, it asks us to add a rainfall in millimeters column. So I'll put the title here in millimeters. It's good to put the units up top because you cannot put the units in these individual cells. Because if you do, it won't be a number anymore or a formula, it'll be a label, and we can't do calculations with labels. Now for the rainfall, it says we want to put it in millimeters. We have the rainfall value in inches, so we need to have a conversion factor between the two, and it does point out in the assignment that there are 25.4 millimeters in 1 inch. So I'm going to start a formula. I'm going to take my value in inches for rainfall, D2 in this case, and there's 25.4 millimeters in an inch, so I'm going to multiply by 25.4. Let's see the result I get, 408 and change. Now the sanity check here is, remember whenever we do a calculation, Excel will happily do it, but we want to check, does it mean anything? Did we make a mistake or not? For millimeters are much smaller than inches. So if I get 16 inches, I should see a large number here. And if you're at all uncertain about any of the calculations, feel free to change one of the numbers you started from. So instead of 16, I can just enter 1. And it will show me 1 inch is 25.4 millimeters. That's exactly what was shown on the assignment. When I'm done, I hit Control-Z, undo, to get back to my original data. So that's a nice way of checking. Did I get that right? Maybe I divided instead of multiplied, or did a wrong conversion. That will tell us. And now, since I've done it for the first formula, D2 times 25.4, I'll just use the autofill here. Hover my mouse over the bottom right of the box. Drag down, let go. It fills it all in. I'll just check one at random here on row 19. And sure enough, the formula is D19 times 25.4. So it did the right thing. When we use the autofill, it will automatically sort of adjust the cell references that are in my formula. So it's using, if I move down, it will move the reference down as well. If I move to the right, it'll move the reference right. We've seen that before. All right. Now we'll do snowfall, and it's exactly the same calculation. Snowfall in millimeters uses the exact same formula. I'm just going to take the snowfall in inches and multiply it by 25.4. There's just as many millimeters in an inch for snow as there is for rain. And instead of doing autofilling all the way down, there's my formula. Instead of autofilling all the way down, I'm just going to do the first formula all the way across and then autofill the whole kit and caboodle down when I'm done. That's a sort of a quick way of doing it. And it just shows that once you get that first formula right, autofill can do all the rest. And the next column it asks is just the total precipitation in millimeters as well. And that will just be the sum of the rainfall and the snowfall. I could use the sum function, but we hadn't covered that yet by this point, so I'll just say equals rainfall, F2. I like to use the mouse to pick my cells, but you can always type in G2 here instead of using the mouse. Either way, once I hit enter or click somewhere else, I get my result. That looks right. I do a little sanity check in my head. Yeah, that's about 1800, that's about 400. Add them together, 2200, close enough. That tells me that my formula is probably right. Now the next one's a little tricky. Temperature in degrees Celsius. Now, the interesting thing about temperature is it's not a straightforward conversion because Fahrenheit has a different zero than Celsius does. Celsius 0 means 32 Fahrenheit, whereas 0 millimeters is 0 inches. You can do a straight conversion, a multiplication there, but not for converting temperature between Fahrenheit and Celsius. So I'm going to use the formula. The formula is actually 5/9 and then in parentheses the Fahrenheit temperature minus 32. That Fahrenheit minus 32 business equalizes the zeros, and then we can use a ratio, which is 5/9. So I'm going to use the formula equals 5 divided by 9. There's 5/9 times, you wouldn't have to do this perhaps in some if you're writing it out by hand, but you do have to put the times in there. And then the temperature in Fahrenheit, which in this case for Anchorage is cell B2, minus 32. Close my parentheses. And I'll get a lot of decimal places, but I'll deal with that later, but about 2.4 degrees Celsius. So 36 degrees Fahrenheit is 2.4 degrees Celsius. Do I know that for sure? A lot of us aren't familiar with Fahrenheit degrees, so it doesn't really make sense, but we do know two things about Fahrenheit. 32 degrees Fahrenheit is 0 degrees Celsius, and we here in the Yukon know that minus 40 degrees Fahrenheit is minus 40 degrees Celsius. That's when the two scales actually match up. So to test that, I'll just do what I did before. I'll change my data. So for the degrees Fahrenheit for Anchorage, I'll just set it to 32. Enter. 0 degrees Celsius. So that part is right. I'll hit undo to go back to where I was. And I'll change 36 to minus 40. Degrees Celsius, that's minus 40 as well. So I must have done that right. You always want to take 2 points when you're doing a conversion like that, just to make sure you weren't lucky on the first point. All right, so we've got our temperature in degrees Celsius, which we need for a later calculation. But first it asks us to find the wind speed in meters per second. That's I guess the metric way of measuring the wind speed, but in the US they measure it in miles per hour. Now that's a complicated conversion. We have to go miles to meters, hours to seconds. Or we could figure that out that way, or we could just use trusty old Google, which will do a lot of our conversions for us. If you just say 1 mile per hour to meters per second. And you can probably type it in various ways, but this will work. 1 mile per hour to meters per second. There it is, 0.44704 meters per second. So I'll just copy that. Be nice and accurate, get all my decimal places. Back to my spreadsheet. So 1 mile per hour equals that many meters per second. So my formula will be whatever the miles per hour is, C2 in this case, times, and then I'll paste in my conversion factor, 0.44704. Now in this case, I'm at a bit of a loss to know to apply a sanity test. Is 7 miles per hour 3 meters per second? I'm not really good at that, so I'll have to sort of take that on faith, or perhaps I can figure out a way, but of coming up with some way of arguing that seems to be in the ballpark. But it doesn't seem impossible. 3 meters per second would be a pretty fast walk, as would 7 miles per hour would be a good run. So I guess they're about the same. I guess they both be running. Now it asks us to add the wind chill in degrees Celsius. Now this is a complicated formula, and it's an old one. It's not one that we use anymore, but it is. It will show us that we can use very complicated formulas. This one is based on temperature in degrees Celsius and wind speed in meters per second, which is why we had to do that conversion first. And the formula is, I will start with an equal sign as I always do, and it's given the formula here, 0.045 times, open parentheses, very important to get the parentheses to get the order of operations correct, 5.49 times, and then this odd thing, SQRT, and then in parentheses, the wind speed in meters per second, which in my case would be J2. SQRT in the parentheses is the square root function. We'll see square roots in the next topic, and we'll see functions in the next topic. Square root is a function. We give it a value inside the parentheses, and it will just take the square root of that and use that in the calculation. So we'll see lots of examples of functions later. But we continue on, 5.81 minus 0.56. Notice I don't want to put any spaces in my formula. Odd things can happen. It asks for the wind speed again at this point, J2. Close my parentheses, times, open my parentheses again, 1.8 times the temperature in Celsius, which is I2 for Anchorage, minus 59.4. Close my parentheses and add 33 at the end. Woof. That is a formula, but you can get far longer than that in Excel, and we end up with a wind chill of minus 1.25 degrees Celsius. Now, again, how would we know if that's the proper wind chill? If that, do we have a good sanity test for that? Not really, but we can guess that if the temperature, we have the temperature and we have some sort of wind, that tells us that this temperature should be lower than the temperature without the wind. Because wind chill always makes it feel colder. So that makes it feel a little bit colder. It was a little above zero with the wind, a sort of moderate breeze there. It will make it go below zero, feel below zero for our wind chill. All right, now I've done all these calculations. I'm going to select all of them and use autofill to do all of them in one stroke. Oops, for my entire worksheet. I scrolled over as well, but that's fine. And you'll see it fills it in all at once. So as soon as you get that first row of calculations done the way you want them, you can just use autofill to do the rest. And you can check any of them to see that yes, it's using the right rows. So this calculation here in row 18 is using this cell in row 18 and that cell in row 18, the temperature and wind speed. So it's doing the right thing when I used autofill. And it's coming up with the correct calculations. So let's see what we have here. Minus 23, look at that for Barrow, Alaska. Minus 23, average wind chill all year round. That's pretty chilly up there on the North Slope. We're not surprised to find. Now it asks us to format all of the numbers so that only one decimal place is shown. We've got too many decimal places over here. We're a little inconsistent, for instance, this temperature doesn't have any decimal places. It should really be 35.0 to make them all consistent. There should be 11.0 for the wind speed here, and for all of our calculated values should be one decimal place, excuse me. There's no units, there's no dollar signs or percentages, so I'm just going to format everything in the entire worksheet. So I'm going to select my entire worksheet. From the Format menu, choose Cells, or I could right-click and choose Format Cells. And I will choose Number, because I don't want any special formatting for currency, percentages, dates, times, and all the rest of it. And I just want one decimal place. Notice I'm applying that formatting to even the labels, like station, temperature, wind speed, anchorage, and net. Those are all labels. But formats for numbers don't apply to labels, so I can skip right by them. And here's our result when I apply them. All of them now have, nice and neat, have just one decimal place. And of course our labels are untouched because they're not affected by number formatting. They're affected by fonts and colors and so forth, but not by the number format. And finally it asks us to dress up the table using one of the built-in auto format styles. And that will work whenever you have a sort of rectangular set of filled-in cells, like I have here. From A1 through K22, I've got what Excel would call a table. It's rectangular sets, like a range of cells that are filled in with labels, formulas, or numbers. And we've got all three going on here. And to do that, I don't have to select anything. I can just click anywhere in my table, and I'll say, from the Format menu, I'll choose Auto Format. And it will give me a selection of different table formats. And I can pick any of these. Of course, you could always make up your own and change it, but I'll just pick this one, List 2. Say OK. And it instantly applies it. It gives me a bold green white title on a green background. It puts in some of these nice horizontal green stripes so that it makes it a little easier to line up the numbers when you're looking at them. And put a bit of a border around the whole thing. Of course, I can always override it and change it to my heart's content later. But that's the end of our exercise.